Okay, let's do. So yesterday I stopped at example 5.3, right? We were looking at hydraulic presses, we looked at some formulas, we looked at some equations, looked at some theory behind it, right? Yeah. Two examples. We'll do example 5.4 now. Okay, on page 122. Yeah? So, they give you the following data, which refers to a single acting hydraulic press. They give you the plunger stroke length, they give you the plunger diameter, the force applied on the plunger, and the ram diameter. Okay? So, if you have to write down this information, plunger diameter is big letter D or small letter D?
Sorry?
Plunger diameter is small, right? So it's equal to 20 millimeters. Coming? Guessing between myself. Right. Okay, plunger diameter is that your stroke length of the plunger is equal to 15 millimeters. The force applied from the plunger, so your F is equal to 400 newtons. Your ram diameter is equal to 60 millimeters. Then they also, why is it? Yeah, I don't know what I'm doing. Right. Then they tell you that the mechanical efficiency of the hydraulic system press or the hydraulic press is 85%. Right? So the efficiency of your hydraulic system is equal to 85%, right? And they tell you that that of the lever system is 80%. So the efficiency of the lever system is equal to 80%. Okay. Before we calculate anything, let us convert to the units that we need. Okay. So this would be 0.02 meters. This would be 0.015 meters. 400 newtons is fine. 0.06 meters, and then that's percentages. Okay? I understand the information that we were given? Okay.
Whoa, what? Okay. I'm looking at this bottom parts there. What sign is that?
It's what you use for efficiency. It looks like an N, but then it's just curved at the bottom. Right?
Where's the parts of the formula?
You see your efficiency formula, the
Okay.
work output, that same sort of, right? Okay, so they just gave you the efficiency of the hydraulic press and they gave you the efficiency of the lever system, right? Okay, so, right. They want to know the volume of liquid displaced after 6 pumping strokes of the plunger. How would we work that out? If you look at the top of page 121, where they tell you the relationship between the ram and the plunger motion. Right? If you see B, where they say volume of liquid displaced by the ram piston is equal to the volume of liquid displaced by the plunger. And then you see the formula that they have below that is pi d squared over 4 times the stroke length times the number of strokes. Are we all looking at that?
Yes.
So what is that equal to? That is equal to the volume of liquid displaced by the plunger. What did they ask us for? The volume of liquid displaced after 6 pumping strokes of the plunger. Same thing, right? So the formula, so you say the volume of liquid displaced by the plunger would be equal to pi d squared all over 4 times the stroke length times the number of strokes. So this would be pi, what diameter is this? The plunger diameter, right? Small letter d. Okay, that would be 0.02 all squared over 4 times. Your stroke length is 0.015, and then the number of strokes you said is 6. So what you get? Hamilton.
10 exponent minus 6.
Say it.
0.0000.
Say it like how they give you the calculator.
0.00.
They give you the gun. They don't give you
No.
as a times 10 to the power.
Yeah, it is on my side.
Why? What you get, Daisy? Is it with degrees?
Oh no.
Okay, give me.
Mine is 2.827 times 10 to the power negative 5.
When your units would be meter cubed, right? You had 0.402827.
Yeah.
Same thing, right? Okay. Right, so this is the same as 0.1234287
The calculator.
2827 meter cubed. So this was the volume of liquid that was displaced by the plunger after 6 pumping strokes. Right? Okay. Next question. Calculate the distance the ram will move in millimeters after 6 pumping strokes. Now going back to that same place where I told you to find this last formula, at B, they tell you volume of liquid displaced by the ram piston is equal to the volume of liquid displaced by the plunger. The question asks you for the distance the ram will move. If you look at the volume of liquid displaced by the ram piston, they got it as pi d squared over 4 times the ram distance. Yeah? The question asks you for ram distance. So we can use that to solve it. So what will we say? We'll say the volume of liquid displaced by plunger is equal to the volume of liquid displaced by the ram piston. Yes? From what that point B says?
Yeah.
Okay. Now we know the volume of liquid displaced by the plunger, which is that value there. 2,827 times 10 to the power minus 5. It will be equal to pi capital letter D squared all over 4 times the ram distance. That's what we're working out. We know this value of D because it was given to us here. Right? So this would be 2.827 times 10 to the minus 5 equal to pi 0.06 squared all over 4 times this distance. And your distance would be equal to you take this number and divide it by what answer you get there.
This is not enough important for
It's the one right in the
One
bottom. But you see that one right in the bottom, volume of the fluid displaced by plunger is equal to volume of fluid that's displaced by the ram.
About 5.2. You can highlight it.
No, that, oh, you remember I told you to add at the bottom one.
The one above 5.2.
Oh, okay.
Okay, but the one right in the bottom was, it's only if it was only for one stroke leg, if there wasn't more than one plunger being pumped. Like see on this one here, the example, you have 6 pumping strokes. That formula that we told you to highlight was for 1 pumping stroke. The formula I told you about now is for numerous pumping strokes, but it's the same thing. It's just that you multiply the number of strokes to the plunger side, that's it.
In fact, you could have actually taken the number of strokes out,
And you end up with that formula in the
and
bottom.
you end up,
Yeah, it's the same thing.
Yeah.
It's just that one is for numerous number of strokes and then one is for
If you took the number of strokes out, you get the actual volume of the
Volume
the
displaced,
piston,
yeah.
and you multiply by 6.
By 6.
Yeah.
guys are everything out in the okay. Somebody did I start recording?
Yeah.
Yeah. Yo,
Guys, what's going on?
I'm getting 9.1.
Check, work out this number first. Write down this number and then put this number over it. Then press the S to D. Convert the number. S to D, the button.
Okay.
No. What should you say? Guys, what's going on?
You got that 9.998.
That's not issue answer.
Okay, 9.998.
It's basically almost the same.
Yeah.
It's the same number,
Yeah, it's
except that it's not 10 to the 5, it's 10 to the 3.
Oh, Jesus. Why you 10 minutes?
Guys, you're not overthinking this. Just take this number and divide it by the area formula.
It's 10 to the 3. It's 10 to the 2.8727 times 10 to the minus 3. Right.
You're getting minus 3.
Yeah.
You're getting
no.
2. You're getting minus 10 to the minus 3. Wait, which page you turned in? You saw 10 to the minus 3.
It's 10. How much is it?
Oh my
10 to
god,
the
guys.
minus 5.
No, it's 0. It's 0.
Okay, guys, give me what this number is. Pi 0.06 squared all over 4. What is this?
0,002.
So, it is
0,002827.
0.00287, right? And then
27.
put 2,827 times 10 to the minus 5. You're going to end up with,
How much is
okay,
that?
yeah, you're right. Okay. 0.0001.
3 zeros, 1.
3 zeros.
Yeah.
No.
2 zeros.
Oh, 2 zeros.
2 zeros.
What? 2 zeros?
Times 10 to the minus 3,
No.
minus 5
No,
over.
not 10 to the minus 3, no. It's 0,01. 0,01.
1, 2, 3.
0,01.
Okay.
Yes.
Guys, just put this in your calculator. Put this 0,123. How many put 4? 2827. Put that in your calculator.
Yes. I'm telling you, it's 0,01.
You're going to end up with.
How are we doing then?
Are we? I don't know why I'm doing maths in science. 0,01 meters. What the question asked you to be? Millimeters. So you multiply it by 1,000. So 0.01 times 1,000?
10.
Oh, why can I not say millimeters? Right. That is the ramp distance. Okay? I feel like I forgot the whole method to after this whole situation, right? What happened was, the first question they asked you to calculate the volume of liquid displaced by the plunger, right? That's the formula for it. Okay? Substitute it, you got it. Then they wanted the ramp distance. Now we know from the theory that volume of liquid displaced by the plunger is equal to volume of liquid displaced by the ramp piston. Right? To calculate the volume of liquid displaced by the ramp piston, you would take the area times the ramp distance. What they asked us for?
Distance.
Ramp distance. We know this value here of volume of liquid displaced by the plunger. We know we could work out the area because we know the ramp diameter. So we just solve for the ram distance. Right. Then they ask you calculate the force that is exerted by the ram. So basically they want to know your W. Okay? Okay? All right? So C, what's the formula where we have WF capital letter small letter D?
W over F is equal to capital letter D over W small letter D.
Right? Okay. So W over 400 is equal to 0.06 squared all over 0.02 squared. Right? W is equal to
Six.
Hmm?
2,600.
right. But remember they told you at the start that the mechanical efficiency of the hydraulic press is 85%. So is that going to be the actual force that's being applied to the ram?
No, it should be 85% of that.
Yeah, right? So your efficiency formula is, in this instance here, it should be where was it?
Work out.
It would be your efficiency is equal to your actual over.
Work output divided.
Yeah, but in terms of this, your output would be the actual amount that's being applied to the ram,
Yeah.
and the input would be the applied force, your theoretically applied force. Okay, so this would be actual,
Yeah.
and this would be the, let's say, theoretical.
The top one should always be less than the bottom.
Okay, they told you that the mechanical efficiency of the hydraulic press is 85%. Means that the system itself is only 85% efficient. Theoretically, we know that for a force of 400 newtons being applied, it should be able to push up a load of 3,600 newtons. But the system is only 85% efficient. So the actual amount of weight it can push up, or the actual force it will apply onto the ram, would be your theoretical will be 3,600 in theory in calculations, but the actual amount is what we need to work out. So that 85% is 0.85, right? Over, so the actual force on the ram 3,600. You cross multiply, your actual will be equal to anybody else? 3,060. So for an actual system that's running at 85%, if you push down the plunger with a force of 400 newtons, it will push up against the ram at 3,060 newtons. Do you understand? You get it?
Are you gonna do another example? Because I'm lost.
Which part?
Wait,
Without it.
wait,
From here. From here to?
No, I from C.
From here.
From where?
See,
no, wait, yeah.
from here.
Yeah. Yes.
Okay.
The 0.85,
Even-
why
even-
0.85?
Because it's the mechanical efficiency of your hydraulic press.
Yeah.
What
Oh, no,
is
okay, this thing says 85, right? But by putting 0.85, you divide it by 100.
Yeah, it's a percent,
Okay.
right? So it's 0.85.
Yeah. No, I'm not saying it's wrong. I'm just saying. Yeah.
Now remember, 85% is 85 over 100, right? Okay, so to explain what's going on here, right? The question asks you to calculate the force that's exerted by the ram. Okay, exerted by the ram is basically, remember, in the situation we had here, right? You have your plunger which is pushing a force down, right? Right. You have your ram on this end with a with a force that's being applied onto the ram. So we call that W the supported load, right? So when this pushes a force down, that force with whatever liquid is here with the hydraulic, because hydraulics is fluid, right? Will push this up to support the load, right? So the question wants to know, if you apply a force of 400 newtons, what force will it actually have on the ram? What force will be applied to the ram? Right? From this formula here, this would be the force that's applied from the piston, from the plunger. This would be the force that's applied onto the ram. Understand? Right. We worked out the force theoretically to be 3,600 newtons. You are fine with that? Like how we did it yesterday and stuff? That's it. Okay? But they told you that the efficiency, you understand efficiency, right? Okay? But it's only 85%. Meaning that the system at 100%, where there's nothing else acting on it, where there's no external forces, everything is perfect, this is the ideal system. If you apply a force of 400 newtons, it would act on the ram at 3,600. But is our system operating at 100%? It's operating. Remember, this whole system is a hydraulic press. They told you the efficiency of the hydraulic press is 85%. So the force that would actually be exerted onto your ram would be 85% of that. Get it?
No, I get it.
Right? So your efficiency will be the actual force that's being in reality over the theoretical amount that you would have calculated, which is why I said 0.85 is equal to the actual force on the ram over the theoretical, which was 3,600, and then we get the actual force being applied of 3,060. Get it? Getting
What
better.
formula you use?
Where?
That second was one.
This one. It's your efficiency, that work output
That will be with efficiency.
over work input, same thing, right? But your output in this case would be the actual force on it, the input would be your theoretical. Efficiency, your other formula for efficiency is actual over theoretical. Okay? We're okay with that, guys? Yeah. Then they tell you, okay, so the effort that must be applied to the lever in order to obtain a force of 400 newtons on the plunger if the mechanical advantage of the lever system is 10. Okay? Now, what's our formula for mechanical advantage? What it is? Huh? It's the force on the plunger over the effort on the handle at the top of page 121, right? It would be the force of the plunger over your force on the plunger is your load basically, right? And then the effort on the handle would be what you basically pushing down. If you look at page 120,
The E and the F.
the E and the F one, right? Your effort on the handle will determine how much force is actually being applied. Now in the question, they want to know, what is the effort that must be applied to the lever in order to obtain a force of 400 newtons? So, okay, so this is D. Your mechanical advantage is equal to load over effort or the effort on the handle and what's that one?
Force of the plunger. Force on the plunger.
Okay, so they give you the mechanical advantage to be 10 equal to load over effort. Okay, your load will be 400 newtons, the force of the plunger, right? So your effort will be equal to 400 over 10, which is 40 newtons, right? So meaning that you need to push down on the handle with a force of 40 newtons to actually get the plunger to create a force of 400 newtons. Theoretically, what other efficiency they gave you?
It's
80%.
What is that 80%?
of the lever.
Of the lever system, right? So, efficiency in this instance would be the actual force on lever or actual effort on handle, sorry.
So all these formulas we won't be given all of this,
I need to check the data sheet, right?
because it's actually a lot.
I think it's easier if they give you a drawing because you can
Visualize it,
Yeah.
right? The efficiency of it is
80.
80, so that will be 0.8 equal to the actual all over 40. 40 times 0.8,
32.
Yeah.
right? So, your, sorry, it's supposed to be,
Yeah, it's 80%.
Oh, sorry.
80%.
it's supposed to be the actual over applied.
Oh. The response is right.
Right. See that? Remember, in well theory,
Should be more actually.
should be applying more
Yeah.
because the system is only 80% efficient, right?
Right.
So if the system is 80% if the system was 100, you only need to apply 40 newtons. If the system is less than 100%, you obviously need to apply more force to still get out 400 newtons.
Yeah.
You understand what I'm saying?
Yeah.
Right? This is all more understanding questions, not formula based, because efficiency you can play around with later, right? So, for you to get an output of applying 400 newtons, your input would obviously need to be more.
Because of the inefficiency.
So, for you to actually get 40 newtons, 40 newtons applied, you need to apply
50.
50.
Yeah.
15%.
So that will be 40 over 0.8, which will be 50 newtons. To explain it so you understand, again, so we worked out using the mechanical advantage is equal to load over effort, right? Your load would be the force that's applied onto the plunger over the effort that was applied to the handle. The question wants to know that, how much effort do you need to apply? We know the force on the plunger is 400 newtons. We know the mechanical advantage is 10. So we calculated the effort that would be required in a perfect system would be 40 newtons. Right? But we know that the mechanical efficiency of the system is
80%.
80. So what you are applying to it will obviously have to be more for you to get that 400 newtons. You understand that? Okay, so for a 100% efficient system, you will need to apply an effort of 40 newtons. But the system is not working at 100%, right? It's working at less than 100%. So you're going to need to put in more effort into that handle for you to still get that output of 400 newtons. Right? Just think of it as when you bought this machine, it was working perfectly. So it was very easy to push down the handle. After time, maybe the mechanism is getting old now, and you obviously need to start pushing it down more, right? With more of a force to still get that same displacement. So, for you need to even look at your formula to see how it would make sense, right? You know that your answer you get needs to be bigger than the force that was applied. So, your calculation will have to look something like, your efficiency would be equal to the actual effort on the handle, which is what you would normally put at 100%, over what you're actually applying onto the handle to get it at 400 newtons. So that's why I have 0.8 is equal to 40 over the actual applied force, which would be 50 newtons. So the actual effort that's being applied or the being applied onto it in reality is 50 newtons for an 80% efficient system. I feel like you're all just
Now, I get it. Maybe this is an example, right? Say for instance this classroom, got enough desks to handle say 20 people. But currently we only got 10 people in here. So the efficiency of the classroom is only
It's
50% of what it should be.
Yeah.
Whereas like you're only doing like basically you're teaching 50% of what you could be teaching.
yeah.
So that's basically what's happening. The losses are the empty desks. That's what he's basically saying.
I don't know if I get it. Yeah, me too. Go back and practice it, right?
Yeah.
That was D. Then we want to know.
Sorry, if you get a question like this, right, and you draw that drawing in hydraulic press. Well, I think it's easier to understand with
Yeah,
the drawing.
that's fine if you
So we can use the drawing for any question.
for hydraulic
figures.
press
Yeah,
question.
as long as it's hydraulic press. I think it's easier that way.
Yeah, you
Because
can.
now these descriptions and this if you can see the drawing in your I'm pushing the side and need to get a result there on the other side. If there's inefficiency,
Must I do the drawing?
Oh, the yeah.
Okay, see it, right? Remember this drawing here? Okay. Right. Looking at this diagram, right? And then I'm going to draw my. That's my angle. Okay? So, we know now that this is your plunger. Your plunger diameter is given to you at 0.02 meters. Okay? So this here is basically small d. Okay? The force that was applied onto the plunger is 400 newtons. Okay? The diameter of your ram, capital letter D, so that's your ram, would be equal to 0.06 meters. Okay? And then they tell you the stroke length of your plunger. When you applied a force onto it, it basically moved 0.015 meters. That's what that information is telling you. Okay? The efficiency of the hydraulic system means that from the plunger all the way to the ram, the system operates at 85% efficiency. Okay? The efficiency of the lever system, so this part here where you push the handle down, where you apply effort on the handle to create the force on the plunger, is only 80%. Right? So for the first question, when they asked you to calculate the volume of liquid displaced by the plunger, means that for the 0.015 meters, how much liquid actually moved from here to here in volume? Now, how you would work that out? It would obviously be the area of the circle multiplied by that length. Right? Can you see it? Right? Because that's how much you can only push. How much that circle can push down for that length. That will give you the volume. And remember, volume of a cylinder is pi d squared over 4 times the height. The height in this instance is your stroke length. But because it was being pumped for 6 times, you obviously going to be moving that amount of liquid times 6, which is what we did here. Cool. Right. Then they asked you to calculate the ram distance. What is the ram distance? When this applies the force and it displaces liquid, where is that liquid going? It's pushing this up, right? So this would move for a certain distance. Well, actually, the ram itself will move for a certain distance up, and that would be your ram distance. And how they came up with their formula is volume of liquid displaced by the plunger is equal to the volume of liquid displaced by the ram piston, because how much volume was pushed down here has to push this up, can't go anywhere else, right? It's not going to evaporate. It's a closed system. There's no gaps in that. Okay, I understand that. So that's how we got the formula over there, because it can only move by your area of the circle and the distance that it would move. That's how much that volume would move up, right?
Yeah.
Right. That's how we work that out. Are we okay then?
Yeah, still good.
Okay. Where's question C? Right. Question C, they want to know the force that was applied onto this ram diameter. Because we applied a force of 400 newtons on this end. How much did it actually push up the ram diameter? What force did it push up the ram diameter by? And that's when we use this formula here. And we worked it out 3,600. Theoretically, if you apply a force of 400 newtons on this plunger, it would push up this ram with a force of 3,600 newtons. But the system is 85% efficient. So it's not going to push it up by 3,600, it's going to push it up by 85% of 3,600, which is 3,060. Do you understand that? And why I did it like that? Right. Then they came to the part when they told you that the mechanical advantage is 10. Calculate the efforts that you needed to apply onto the handle to create this 400 newtons. Okay? So, your mechanical advantage is equal to the load over the effort being applied. Now your load is 400 newtons that's pushing down. How much effort did I need to put on the handle? The effort I needed to put on the handle was 40 newtons to create the 400 newtons on the plunger. But for this lever system, it's only 80% efficient. Now if it's only 80% efficient, I have to apply more force on it to get it to 400 newtons, right?
Okay. Yeah, that makes sense.
Which is why I took the effort that I needed to apply and divided it by 80%. Because it will give me a higher number than the theoretical amount. Do you understand it? Does it make more sense now?
Yeah. It
I
does.
feel like you're skeptical. Does it make more sense?
No,
It does.
I was confused. I'm following now.
Okay. So if you actually read this diagram is you can visualize the things a bit better. Okay? You know your plunger is on this side, your ram is on that side. If volume pushes down here, it has to pick it up by that side. Then it helps you even in remembering the formulas.
Yeah.
Because you can visualize area times the distance is obviously volume.
Yeah.
And then you go. Now there's one more question there, right? The one more question they asked you is the mechanical advantage of the hydraulic press. Okay? Mechanical advantage is equal to what? Right. This is not the mechanical advantage of the lever system. Remember, the lever system is just the lever and the plunger.
Yeah.
They're asking for the mechanical advantage of the hydraulic press. The hydraulic press is everything excluding the lever. Okay? So it's basically plunger to ram. Right? Now, mechanical advantage is equal to load all over effort. What is the load here? Where is the load here? On this end, right? It's that W that you would normally see pushing up, right? Because that's the load on the ram.
Yeah.
The effort in this instance, in the hydraulic press, would be the force that's pushing down.
Yeah.
You can understand that? Okay? So, what is the load? What is the value of the load here?
3,600.
For the system,
Oh,
this specific system, it will be 3,060 because it's only 85% efficient, right? So this will be 3,060 all over 400 because the effort being applied is 400. What's the answer?
Seven point six five.
3.65.
7.65. That's your answer.
What's the unit?
No, there's only this mechanical advantage.
Cancels out the newtons divided by
Newtons.
Yeah.
Guys, do we understand what I said?
I think for me, when I get this question, I just go for a drawing.
Yeah.
It's easier to make sense of it when you look at the drawing.
Okay, take it on the meantime.
If they didn't give us the efficiency, right?
Okay, now I'm looking at example 5.5. There's only one more thing on hydraulic presses that we need to discuss. It's not a new formula or something. It's something called slipping. Right? You'll see it as part of this question. Slipping is basically an inefficiency in a plunger. Right? So they'll give you a slip percent. So you know your plunger, when it's normally pushing down, it's gonna, after a certain maybe wear and tear or something, it doesn't go back or come back to the same place. Like, you know, when it goes down, it may go 10% less than the actual distance it's supposed to, because it slipped out, right? That's basically slipping. So have an example 5.5. And also the diagram, remember, is for a single acting hydraulic press, right? Where you only have one piston that's pushing down, basically, right? So let's draw the diagram.
You were
So
told
an
in
exam,
RD.
they're obviously going to give us one more than one.
No, there's an NRD, I think, with 6 strokes. When the thing comes back, it's gonna.
No, but it's a one piston acting. So
I know
you
what
can
I'm saying.
pump up and down how many times.
The liquid will get coming back. That's what I'm saying, there's an NRD there. You pump the first stroke, the liquid goes across. You pump the next stroke.
No, but remember with the force you pump it, the liquid is gonna get displaced, right? Because of the force it's being moved. Now remember, this happens more like quickly. So by the time it picks up, the liquid is not gonna rush back because of the force that was applied. It creates a pressure that moves it. But don't confuse yourself. You don't confuse
No, I'm not
yourself.
confusing, I'm trying to, that's how it doesn't make that side, so. That's what I'm thinking of.
Being practical.
I mean, yeah, in practical terms, that's how it should be.
No, the slippage is not.
No, it's not big.
Check.
I'm talking about, you said 6 strokes. Obviously, if you do this, it's gonna thing. So I'm saying you're pumping the first stroke, it goes up. So then you coming back, pump the next stroke, it goes up.
Okay, so they tell you your plunger diameter is equal to 90 millimeters. So remember, this is your plunger side, this is your ram side. So your plunger diameter, which is small letter d, is equal to 90 millimeters. They tell you your plunger stroke is equal to 150, meaning the stroke length is equal to 150 meters. Your plunger stroke length, right? Your ram diameter is equal to capital letter D, 440 millimeters, and then they tell you the slip is equal to 10%. Right? That's the information they gave you. Then, okay, let's get our values in correct units. So this would be 0.09 meters, this would be 0.15 meters, this would be 0.44 meters. Right? Everything is fine. Now, calculate the actual volume of liquid delivered to the ram per stroke. Right? So they want to know how much liquid after this pump was delivered to the ram. That will be equal to the volume of liquid that's displaced by the plunger. You agree? Okay, so volume of liquid displaced by the plunger. That will be equal to, what's the formula? Now remember, the stroke length, it's basically that amount of volume, right? Whatever is there. What does this look like? What shape? A cylinder. What's the volume formula for a cylinder? You remember, you all need to know this for centroid too as well.
Yes.
So you might as well memorize the formula. It's what? What's the area of a circle? Pi r squared or pi d squared over 4, right? That's the area that will give you the formula, and you multiply by the height. Trying to give you a ways to try and remember this, right?
Yeah.
That volume displaced is like a cylindrical amount of volume being moved, right? Formula for cylinder is pi d squared over 4 times the height. In this instance, your height is your stroke length, right? So this will be multiplied by stroke length. This d is small letter d, yeah? Okay, so pi small letter d is 0.09 squared all over 4 times 0.15 meters. So what was the volume that was displaced by the piston? Oh, sorry. I was moving too fast there. So that would be the actual amount that would be displaced, right? But remember, because of your percent slippage,
Okay.
right? Slip percent is basically an inefficiency on the plunger. So if they tell you 10% slip, it means that the plunger operates at 90%. I understand what I'm saying? Okay? So you also have to multiply it by the efficiency of what the plunger would be. You get what I'm saying? If it slipped 10%, that's the inefficiency of it. Its efficiency would be 100% minus 10, which is 90%. So you multiply this number by 90%. Yeah, you're okay with that?
Yeah.
That can't be a difficult thing, yes?
No, I get it.
No.
It's fine, right?
Yeah, it's just lost the puzzle.
So that's, but then they haven't done it yet.
They did this, pi d square over 4 times 12 times 0.9. Okay, so just remember slippage or slipping is an inefficiency on your plunger. That's the only other thing that I think that they can throw you off from electronic computers.
So 95, 88.
Oh, 0.9.
How many zeros?
4.
0 point?
30, 0.30.
1, 2, 3,
85.
9 meters
Yeah.
cubed. Right? Remember units for volume. Units for length is meters, area is meters squared, volume is meter cubed. Right? Okay. That's volume of liquid displaced by the plunger. Then they want to know the distance moved by the ram after 10 pumping strokes of the plunger. So remember from your diagram, right? This volume that moved when this plunge moved down to this point, that volume of liquid pushed this up by a certain amount, right? So this is your ram distance. Okay? So the same volume that it moved down here should be the same volume that pushed up there. So we get the formula volume of liquid displaced by plunger is equal to volume of liquid displaced by the ram, right? We know this value because it's 0.000859, right? But remember they told you the distance moved by the ram after 10 pumping strokes of the plunger. So you'll have to multiply it by 10, like how we did the previous question when we worked it out, right? Equal to the volume of liquid that's displaced by the ram. That formula would be the area multiplied by the ram distance. Okay, so that would be pi d squared over 4 times. Okay, so anything else we took into account is the number of times that was being pumped. Okay, so you're going to end up with 0.00859 equal to pi. Your diameter of your ram is 0.44 squared all over 4 times ram distance. Therefore, the ram distance is equal to, please don't do what you did before in the other question. Work this one out and then just divide that. So, 17.701 meters. Okay, so that's how much the ram. You sure?
Yes. I got the same.
Oh,
Yeah.
this is a
Like, let's see.
You know how ready to see two people make the same mistake. Because when I saw the dog myself, and she said she also got the same thing. Did I do something?
0.056.
0 point?
0.5.
65 meters. The answer in the textbook is wrong. Right? I tried to see how they got that. I cannot for the life of me get that, right? You all got that, right? Okay, can I take out the set?
Yes.
Right. Temba, what's the next question?
I'm probably doing the same answer, 17.
So, you would have, oh, because you're doing it the other way. You're dividing that number, you're saying that, can I switch to get the same thing? Okay, anyway, let's say that. Your area of this would have been pi 0.44 squared all over 4. Then, that gives you 0.152. Okay? 0.152. Then 0.152, you take 0.00859 divided by 0.152, which gives you 0.0565. Right, you got it now. Temba,
Yeah.
what is the next question?
The work done by the ram piston during 10 pumping strokes.
Okay, so now they want to know the work done by the ram piston during 10 pumping strokes.
If a force of 400 Newton is applied,
If a force of 400 newtons, how many newtons?
400 Newtons,
Okay, so your force is equal to 400 newtons being applied by the plunger. Right. What is our work formula from everything that we did in engineering science? Work is equal to what? Force times distance, right? Work is okay, so work done is equal to force times distance, right? In terms of the ram piston, what would be the force? Where's the ram? The ram piston is the same, right? What would be the force? What would we call it? W, right? W that's being applied upwards, right? And what would be its distance? Its distance would be the ram distance. So the formula we're basically getting for work done is equal to W times ram. Do you agree? Okay, so the work done by the ram piston, or work done on the ram piston, that, right? Okay. We know the ram distance. Do we know W? No, we need to work on W. So, W over F is equal to capital letter D over D squared. Yes? Yes. We know F, we know capital letter D, we know small letter d. So, W over 400 is equal to 0.44 squared all over 0.09 squared. So W is equal to
I was giving up on calculating.
yeah, I don't know if you're like giving up. Yeah.
Zero.
9560 newtons, right? That's the force that's being applied onto the ram piston. Therefore, the work done would be equal to 9560.494. Remember, we took into account the 10 pumping strokes when we calculated this number. You understand, right?
Yeah.
Okay, so that will just be multiplied by 0.0565. And what you get?
$540.168.
540.168 joules. Are we all okay with that?
Yeah.
One more question. calculate the actual work done if the efficiency of the press is 85%. They want to know the actual work done if the efficiency of the press is 85%. So at 100%, you would have 540.168 work being done onto the RAM. Okay? If it's running at 85%, the work is obviously going to be less.
Yes.
Yes.
Yeah.
So all you need to say is the actual work done is equal to 540.168 times 0.85. Right.
Wait.
459 joules. So that's the yes.
That 540.168,
Yes, sir. Talk to me.
isn't that at 90%? Because we remember we took into consideration because it's
Yeah.
got a slip of 10%.
Yeah, but remember that slip is on the plunger, the efficiency of the plunger.
Yeah,
So we took that into account when we calculated the volume that was actually displaced,
right.
right? Then we used that volume and we multiplied it by 10 because that volume is specific to one pump. It was pumped 10 times. Okay? So after 10 times, 0.0859 meter cubed of volume moved
With the slip of the 10%.
with the slip of the 10%,
Right.
and that caused a ram distance of 0.0565.
Right.
So that was taken into account.
Okay.
Then they tell you that the efficiency, so then we use that there to work out the work done for the system with all its conditions like that,
Okay.
right? But then they tell you that the system
So that's
calculates.
the work done, not at 100%.
Yeah, well,
It's a work-
technically,
a work
it's
done.
at 100% given what you have in that system.
Okay.
Taking into it's 100% with the slip. You get what I'm saying? So the condition at what it is there. If they're telling you that, calculate the actual work done if the efficiency of the press is 85%, if 85 times whatever the work is. That slip is included into a system.
Okay.
So don't overthink that one. Just multiply by 85.
Yeah, 85 point, the 85%, if you look at the 100%, it takes into account, you
The
can't
10,
add the
yeah.
10% slippage because you can't, then it will be like 110%. Can't be.
I'm checking that out, right? Right. So now we look. Okay. So now we covered hydraulic presses, right? They give you a summary of your important formula on page 124 and the top of 125. Before we carry on, are we okay with the hydraulic presses?
Yeah.
More or less. You're going to practice it more. You're going to get it, right? But yeah. Okay. Now we're on hydraulic pumps and I'm looking at page 127. So, hydraulic pumps are used to transmit liquid vertically, horizontally or against a pressure. The volume of liquid transmitted has a weight due to gravity and must be transmitted over a certain distance or a height. When a force is moved over a distance, work is obviously done. Because what is work? Force times distance. So when a force is moved over a distance, work has been done. To deliver a liquid at a pressure, centrifugal pumps, piston pumps or potential energy may be used. So they give you a diagram of it, right? So you can see your piston or your plunger on the right hand side and then the liquid that's being delivered. So on the next page they tell you, see figure 5.11. If the plunger moves upwards, what's going to happen? Valve A is opened. Now when valve A is opened, liquid is sucked in from the reservoir, or basically your suction side, right? So when you pull the plunger up, A opens, and what happens? That chamber starts to fill with a liquid, whatever liquid you want to pump. Then when the plunger is moved down, valve A is closed and valve B is opened. You get it? When valve B is open, the liquid is now being discharged. So your reservoir side will obviously be a suction side the B side would be the discharge side. So when you pull that piston up, it sucks in the liquid. When you push the piston down, pushes out the liquid. Right, cool. In the simple situation above, water is only delivered when the plunger is going down. To secure a more regular stream of water, 3-cylinder single-acting pumps are used. The pumps are connected to cranks, making an angle of 120 degrees with each other, and these are connected to an axle. So basically, when the axle moves, it's going to open all the pump. The pistons are going to move up at the same time. Liquid is going to go in to the 3, and then it's going to push down, and it's going to push the liquid out. Okay. So work done by a liquid due to its height. Any liquid on a higher level than the outlet can do work because of the potential energy it possesses. Water in dams or tanks can be used to supply water under pressure, and that work done is basically your potential energy, which is mgh. Mg is force, the gravitational force, multiplied by height, and that height is also displacement, which can be said S. Okay. Work done to deliver water against a pressure. Many practical situations we need to deliver water against a pressure, for example irrigation, pumping water into reservoirs for cities, or spraying herbicides. The volume of water delivered has a weight due to gravity. When pumping the water, it is transported over a specific distance, and when a force acts over a certain distance, work is done. I've said that again. If all losses are ignored, it follows for a piston pump that work done is equal to force times distance, right? Force is also equal to pressure times area. Now remember that. Pressure is equal to force over area. If you make force the subject of the formula, it's going to be pressure times area. Distance, okay, times distance. So, distance over area is what? Distance times area is what? Volume.
Distance.
Distance times area is volume.
Volume, yeah.
Right? So they ended up with the formula work done is equal to PV, which is pressure times volume. Highlight that, please. This is how they derive all these formulas. You don't need to know that. All you need to know is work done is equal to pressure times volume. Okay? So in hydraulic pumps, you know that work done is equal to your force times displacement if work is done by a liquid due to height. And then for work done to deliver against pressure, your work done is equal to pressure times volume. Can you take this out now?
Yeah.
It's not funny.
Yeah.
Okay, good. No, yeah, just carry on. Okay, then be watching the video. We'll start here, then I'm going home after that. Right. Okay, so they tell you calculate the work done per delivery stroke. Example 5.6. Per delivery stroke of a single acting piston pump with a piston diameter of 100 millimeters and a delivery stroke of 150 millimeters. So, this diagram here, so remember that was one chamber, this was also one chamber, right? Remember we said the liquid is discharged at a pressure here, and your piston here basically pushes down, right? So they tell you that your piston diameter is 100 millimeters, so the diameter is equal to 100 millimeters, and the delivery stroke is 150 millimeters. So your stroke length is equal to 150 millimeters. The pressure in the delivery pipe due to the delivery stroke is equal to 220 kPa. So you can visualize it, right? Okay, so if this is pushing down, this would actually be open. So this is what's happening now. Okay? Now you convert all of these to its correct units. So Pressure would be in pascals. So this would now become 220,000 pascals. This diameter is 0.1 meters and the stroke length is 0.15 meters. Right? We said that work done is equal to PV, pressure times volume. Pressure times volume, it would be pi d squared over 4 times the stroke length, right? Because that stroke length is basically the height that this basically moved, right? Or the volume of liquid that was basically moved. So pressure is 220,000 pi 0.1 squared over 4 times 0.15. That's equal to 259.181 joules. Okay. Yeah. Okay, buddy? Fine. Okay. Let's do example 5.7. Okay, so example 5.7, they tell you calculate the volume delivered during 100 strokes at a pressure of 230 kPa if 320 joules per stroke is required. Okay, now they want to know what is the volume. So, there's the information they give you. Okay, so the volume delivered during 100 strokes. Okay, right. That's the information they gave us. How do we work it out? They want to know the volume that's being delivered during 100 strokes. So after 100 times of pumping it, how much volume actually moved? They gave you the work done per stroke. Okay, so if we convert this here into pascals, it's going to be 220,000 pascals, right? Sorry. Right? So the work done is equal to pressure times volume, right? We know the work done per stroke. So we can calculate the volume that's being moved per stroke, right? So 320 is equal to 230,000 times the volume. So the volume that's moved per stroke is equal to 2. That's all.
Yeah.
Okay. So the volume moved per stroke is 0.002
I will 0.001.
per meters cubed. So what should be the volume that's moved for 100 strokes? You just multiply this number by 100. So the volume for 100 strokes will be equal to 0.001 times 100, which is
0.139.
139.
Yeah.
Yeah,
So this number here was more to it.
yeah, all that's one.
How much more? Give me answer 3. You see 3 numbers beside 0.
Yeah, 1391.
Okay, 139 is right, right?
Yeah.
So you multiply this by 139 times 100. So this will be
139.
Times 10 to the minus 3.
Okay?
That's fine.
That's the amount of volume that was moved for 100 pumps. Do you all understand that? Okay, that will tell you, okay? Okay.
I calculate was given it differently. That is, the number doesn't give you with 0.00, it gives you with 10 exponent minus 3.
I'm telling you.
I know.
You see, the first number, you see the 1. The 1.
Mm.
Is the 3.
Time was here.
Go to comma and
Time
that's
was
the
here.
first number you get.
10 times 10 to the minus 3. Is that what you say?
Yeah.
Right? 10. And basically, they're telling you all you need to do is move your comma from here 3 places to the left. So you go 1, 2, 3. So your comma comes there. So the number now would be 0.001. Eh?
Okay.
Okay, before you take it, let me do.
So when we were writing our numbers, we have to put it as 0.0.
You can use either the
10.
exponent or decimals, whichever you
So,
comfortable.
but I think when it gets like minus 6 and
Yeah, when you end up with large zeros, put the exponential value like times 10 to the, because nobody wants to like 0.00, and it's very easy to make a mistake by missing out 1 0 or something like that, right? So just write what the calculator gives you as exponents, right? Let's do example 5.8. So example 5.8, they tell you the work done during the working stroke of a cylinder pump is 4.2 kilojoules. The effective force on the piston is 20 kilonewtons. The piston's diameter is 245. So they tell you the work done is equal to 4.2 kilojoules. Tell you that the effective force on the piston is 20 kilonewtons. They tell you that the piston's diameter is equal to 0.245 meters. Calculate the water pressure during the working stroke. How do we do that? Right? Okay, let's get our values now. We would normally like it. This would be 4,200 joules. This would be 20,000 newtons. Fine with that, right?
Yeah.
Good. So the first question, you want to know the working pressure. What's the formula for pressure? What's the definition of pressure? Definition of pressure?
4,6
On? Pressure is equal to force over area, right? So, pressure is equal to force over area. And looking at the information we have, we could have only used that, right? We couldn't have used the work done value to calculate the pressure because we don't know the height that the piston moved in order to work out the volume. Understand what I'm saying? Right? So, we use this formula here. We know the force that it was exerted was 20,000 over pi. Your diameter is 0.245 squared all over 4. One chance.
Zero point 0471.
Can
Oh, 20,000.
Yes.
36.
424.
416.
Pascals, right? That's the pressure. Then they ask you to, what they ask you? Calculate the stroke length of the pump. Based on the information we have, how would you work it out?
Force, you got the one.
Okay, you can do one of two things, right? You would have, okay, both things you would have definitely used the work done, right? Work done is equal to what? PV, right? And V is equal to pi d squared over 4 times the stroke length. Because the stroke length is the height that would have moved. Like, you just say if it moved to there. The stroke length is that small force, you all agree? Right?
Yeah.
Or because we were given force, we could have also used the formula work done is equal to force times distance. And that force moved for a distance of the stroke length. And something. Yes?
Yes.
All of you get that, right?
Yes.
So we can use that. We know the work done. We know the force. We can just work on the stroke length. So let's use that, right?
Yeah, that's why I see that.
So you'll say work done is equal to force times the stroke length. The work done is 4,200. The force applied is 20,000 multiplied by your and your stroke length is equal to 0.21 meters. Yeah? You understand that? Anybody confused? You're fine. Okay. Calculate the volume of water delivered per working stroke. Okay, so the volume of liquid that was delivered per working stroke, you could have said the area times the stroke length. Right? More than one way to say it, right? Let me just draw this block. Okay. Remember, that's the volume that was delivered. Where the piston was here and it moved here, that gap. Right? That was the volume delivered. So you could have said pi d squared over 4 times the stroke length. Because we have all that information. Or you could have said work done is equal to PV. V is the volume of liquid delivered. We know the work done, we know the pressure. So either or, right? You can choose, you're still going to come to the same answer either way. So you must say work done is equal to PV. Your work done was equal to 4,200 and the pressure is 424,236.416 times your volume, and therefore your volume is equal to. Do you understand what I said there, right?
Yeah.
You're so scared at me. Yeah.
Yeah, that's right.
0.0
99. 0099.
0099. That's it. Meter cube. Okay, that's the volume that was displaced. Okay, they also tell you if they ever had to ask you to write your answers in liters, do you know how to do that? In liters.
I know 1 liter is
1,000 liters is equal to, so make a note of this somewhere, 1,000 liters is equal to 1 meter cubed. Okay, so in the question, if they ask you, to show in liters how much of water or liquid was moved, you work out your answer as normally meter cubed, and then using that ratio, you would just solve for it in liters.
So it's gonna be 9.9 meters. So if you were to
Yeah.
convert, that's gonna be
9.9 liters was displaced in the tank. Last question, they ask you to calculate the mass of water that was delivered per working stroke. How would you do that? They want the mass of water that was delivered per working stroke.
Mass.
Mass.
Yeah, I think there's something I saw that where had MGH or something.
No, they're not. Force is equal to mg.
What formula relates mass and volume? Mass over volume is equal to
Oh, pressure.
mass over volume.
GH.
What rho is? The symbol rho?
Density.
Density. Density is equal to mass over volume. Density relates volume to mass. Right? So, density is equal to mass over volume. What's the density of water? 1000 kgs. 1000 kgs per meter cubed. Okay? The density of water is equal to 1000 kgs per meter cubed. Right? So 1000 would be equal to mass over, and we know the volume that was displaced, it was 0.0099. Therefore, your mass that was actually displaced is viscosity.
No, we use density for.
That's one of water.
Yeah, the oil was 0.85 or something.
You sure that it's not viscosity?
No,
That's density.
you see.
Or the CP of water, the specific heat. You know, we do calculation.
Oh, yeah.
The specific heat is one. It's 1 kilojoule per kg per 1 kilojoule per kg per degree Celsius. One.
Those density.
That was density of water.
Can't be density.
It's 101
Or maybe they're not temperature you're looking at it.
ambient temperature.
No, for us, we're using the calculation for predictors and stuff.
Yeah.
Even when we're calculating the density of oil was 0.85.
What should 9.9 kgs? That was the mass of liquid that was moved. Guys, do we out? Okay. Tomorrow we'll do example 5.9, we'll do example 5.10, 5.11, 5.12, 5.13, and then we done. So we got 1, 2, 3, 4, 5 examples to do tomorrow. Then we done with module 5. Guys, any questions on what we did today? I'm sure hydraulic presses seems much more clearer to you all now with the ram and the plunger.
Yeah, that's the thing. It's more
That's
of
right.
stuff, yeah.
This one here too is also this one with the pumps. They mostly ask you about the work and the volume that was worked. That's that. Very few things. The only formulas you need to know here is W is equal to PV, and the other one W is equal to F times S, and that's work done is force times distance. So actually like the other formula you need to remember is W. Yeah.
Pressure at the piston and plunge is the same.
Yeah. The pressure that displaced it. Remember when we started earlier, we said that the pressure at these points would always be equal, at a level would always be equal. Okay guys, that's it for today. I think that